Hi everybody, here is the video for section 11.6, which is the last section of chapter 11. I'm sure you'll be glad to hear that. And also homework number 43. So please have the following in front of you: the notes for 11.6, obviously the video. And for this video, please have homework number 43 and the theorem sheet with you, because we're actually going to go over homework number 43 in this video. So you want to have it in front of you, okay? Also, the last page that is in your packet for the video, in your notes, we will not be doing. It has 3 separate figures on it. It says find the perimeter and area of the regular polygon. You can take that off the back of your packet, and instead of doing those 3 problems, we're going to work on the homework. Okay. So section 11.6 is about how to find the areas of regular polygons. Now, first question is, what is a regular polygon? Okay, a regular polygon is where all sides, all angles are congruent. Okay, so on this little figure below here, all these sides. Okay, notice I'm just talking about the polygon right now, not the circle. Okay, all those sides are congruent. And all of these angles in the polygon are congruent. Okay, that makes it really much easier to work with. Okay, so please remember that's what makes a regular polygon, and what makes it special. Okay, and you're going to need to remember that in order to do the problems. So the diagram shows a regular polygon inscribed in a circle. Inscribed means something is drawn inside a circle. So notice that this is a 6-sided figure, hexagon, and it is totally within the circle. There's nothing outside of it. And also all the vertices of the hexagon are touching the side of the circle. Okay, so the center of the polygon, center, okay, which is this P right here, okay, and the radius of the polygon are the center and the radius of the circle. Okay, so here we're bringing in the circle. So you've got the center of the polygon, the hexagon, is P. The center of the circle is also P. Okay, the radius of the polygon, okay, let's say P to N, is also a radius of the circle. Okay. So that's important to remember. So anytime you draw a line from the center to one of the vertices, you're drawing a line you're basically drawing the radius of the circle. Now, contrast that, so you don't get confused. If I draw a line from P, the center, to this line right here, that is not a radius. Okay, that only goes to the line, the side of the polygon. It does not go to the edge of the circle, so it is not a radius. And in fact, we have a special name for that particular line. Okay. And the distance from the center, so I'm over here, the center to any side of the polygon is called the apothem. Why it's named that, I have no clue. It's probably in the Greek somewhere, okay? So any line, for instance, this blue line right here, that is the apothem. And here you see apothem is line PQ, okay? So the apothem is the height to the base of an isosceles triangle that has 2 radii as legs. Okay? So let's take a look at this more closely because it's very important. Okay. So the apothem, so we're going to use this blue line, as the apothem. Okay. Is the height to the base, here's the base, apothem is the height of an isosceles triangle. Okay. And notice that there are 1, 2, 3, 4, 5, 6 isosceles triangles in a hexagon. Okay, here's my apothem for that one. Here's my apothem for that one. Here's my apothem for this one. Apothem for this one. Apothem for this one. Okay, so they just happen to choose this triangle up in the right-hand corner to do the explanation. They could have chosen any one of these other triangles. Okay, so you can choose any of those triangles to do your work when you are presented with a circle. Okay, get rid of those extra ones so we don't get confused. Okay. So notice also that the legs of the isosceles triangle, okay, PN and PM, are radius. So these guys are radii. Okay, and you should be making these notes on your paper to make sure that you understand what parts are what. Now, very important, a central angle is an angle formed by the 2 radii drawn to consecutive vertices on the polygon. Okay, so I'm going to change, well, let me first do a little bit of erasure here. Let's do orange. Okay, so the central angle is an angle formed by 2 radii. So here are 2 radii, okay, and they're drawn to consecutive vertices, okay, one right after the other, okay, no vertices in between, okay, and the angle, this angle right here, okay, is called the central angle. Okay. So now to find the measure of each central angle, divide 360 by the number of sides. So let's write that in math talk. So measure of the central angle is equal to 360 divided by the number of sides in the polygon. Okay, so for example, this polygon has 6 sides, so that's equal to 360 divided by 6. Okay, 6 times 36 is equal to 60. So we know that this central angle here is equal to 60 degrees. Okay, so that's pretty easy to find. So make sure that you write all this down and you're familiar with these things, because when we go into doing problems, you're going to need to remember what the radii are, okay, what the central angle is, and what the apothem is. Okay, and it's actually pretty easy once you are firm in your knowledge about what those things are. Okay, let's continue. So here we're going to practice finding angle measures in regular polygons. So remember our formula. Okay. Measure of the central angle is equal to 360 divided by the number of sides. Okay, so that's our formula to remember. Okay, in the diagram, ABCDE is a regular pentagon. Okay, it has 5 sides inscribed in this circle F, and you're supposed to find each angle measure. So let's look at A. So A is the measure of angle AFB. You remember, you have to go in order. So AFB, we're looking for this angle. Okay, obviously this is the central angle, okay, of that triangle, of that polygon. So we just use our handy dandy formula, 360, and since it's a pentagon, okay, 5 sides, 360 divided by 5 is equal to 72, I think. Yeah, 72. Okay, so the measure of this angle is 72 degrees. Okay. Now, they are going to want to look at AFG. So I'm going to try to... Okay, so we know this whole angle is 72. Okay. So now they want you to find measure of angle AFG. Okay, where's AFG? AFG is here. So AFG. Remember, you have to go in order. So we know this is an isosceles triangle, so its base has to be bisected by the apothem. So these two little angles here are going to be equal to each other. It's kind of hard to put on there. So all we have to do is divide the measure of the central angle by 2. Okay, and that's going to be 72 divided by 2 is equal to 36 degrees. And you're going to be doing that a lot. So don't forget that this height here bisects both the base here, the side of the pentagon or the figure, and it also bisects the central angle. So both sides of the angle are equal, both sides of the side of the pentagon are equal. Okay, very important to remember that. Okay, GAF. GAF, okay. So let's look at another color. Actually, I'm going to erase this first. Okay, so GAF is going to be this guy right here. So here we go with good old Pythagoras. Let me take this triangle. I'm going to redraw it, expand it a little bit. So we know that this angle right here is 36. So by now you know what to do. Okay, so we have a 90 degree angle here. Take 180 minus 90 minus 36. Okay, and it turns that the angle is equal to 54 degrees. Okay, so AFB was 72 degrees, AFG was 36 degrees, and GAF is 54 degrees. Okay, so here's GAF. I should have marked my letters. So GAF is equal to 54 degrees. Okay. So once you get the hang of it, it's actually pretty easy. So you have to remember that these little triangles in here are right triangles, and that's going to be really important as you go through this. So all the rules for right triangles apply to these little the halves of the isosceles triangles. Okay. So next on the agenda. Oh, that's an extra. We don't need that one. Okay. So now we're going to use this information to find areas of regular polygons. Okay, now remember, this only works for regular polygons, okay? Not for any other kind of polygon. And regular polygons are really special because all their sides and all their angles are congruent. And you don't find those a lot. So these are truly special. So we're going to use the apothem, okay, to find the area of a regular polygon. So the area of a regular n-gon, remember n stands for any number, it could be 2, 20, 3080, whatever, okay, with a side length of s, here's my side length, is half the product of the apothem and the perimeter. So here it is written in math. I'm going to write it in English. So the area is equal to 1/2 times the apothem, okay, times the perimeter. Okay. So another way to write it is here, because the perimeter is equal to the number of sides times the side length, right? So, because the side length is s, and I know what that length is, all I have to do is multiply it by each side, 1, 2, 3, 4, 5, 6, and I've got my perimeter. So you can calculate this two ways, calculate the area two ways. It always starts out with 1/2 times the apothem, so you always need to know what the apothem is, but then you can multiply it by the number of sides times the side length. Okay, whichever way works for you is good. And the way it's going to work for you is dependent on what information that you're given in the problem. Okay, so what you use whichever formula you have the information for. Okay, so let's go on. So we did the area. So now let's go to the homework. And I'm going to go through this with you because it is a little bit difficult. And I want to make sure that you're ready for the quiz on Friday. So remember, this all is due May 4th, and you'll have your 3 homeworks due, as well as sections 11.5 and 11.6, all due on Friday, May 4th. Okay, so the first question in the homework, and this is homework number 43. Okay, don't forget to put your name on it. Thank you. Okay, so identify the center of the polygon A, B, C, D, E. So obviously we have a polygon. It's got 5 sides, so it's a pentagon. Okay, and the center of both the circle and the polygon is F. Okay, that's pretty obvious. Okay. Now identify a central angle. So remember that you could identify any central angle. Okay, you're free to do whichever one you want. And remember, because there's 5 sides, there's going to be 5 central angles. So the central angle is formed by radius to 2 consecutive vertices. Okay, so here is the central angle. And so you would write angle AFE, or you could write angle EFA, whichever. As long as that F is in the middle, you're okay. Okay. See, FEA, no bueno. Would not be good. Okay, that F has to be in the middle. Okay, so you got the central angle. So I'm going to change colors just to make it easier. Okay, what is the radius of the polygon? Remember, the radius of the polygon and the radius of the circle are the same. So this is a radius. Okay. Okay, and this is a radius. Okay, so the radius, let's pick FE. And what do we know about the length of that radius? The length of that radius is 6.8. Always very crucial in finding these things out, in analyzing these circles. Okay. So now they want the apothem. So remember, this apothem goes from the center point to the middle of the base of the triangle. So our apothem is the line FG. Okay, and we're given that length is equal to 5.5 units, whatever they happen to be. They don't tell us if they're inches or feet or whatever. Okay? So that gives you an idea of the vocabulary. Now, what I would do, or what I would suggest that you do for these, is you try these problems on your own first. And then when you get stuck, or if you want to check your answer, then come back and run through the video. Okay, or you could run through the video first, turn off the video, then try to do the problem. Okay, whichever way. But it's best, don't just take the answers purely from the video. Okay, exercise your brain in trying to figure this out, because that's what you're going to have to do on a quiz. Okay. So the second set of problems. Sorry, I need water. Okay, the measures of the central angle. So find the measure of a central angle of a regular polygon. Again, here's our regular polygon with the given number of sides. Now, if you remember the formula, which I suggest you write in your notes if you haven't done so already, the measure of the central angle is equal to 360 degrees. Okay, divided by the number of sides. Okay, so the measure for number 6, the measure of the central angle is equal to 360 divided by 10. So obviously the measure of the central angle is equal to 36 degrees. Okay, the measure of the central angle, is equal to 360 divided by 18. Measure of central angle is equal to 20 degrees, okay? Easy peasy. I'm going to let you guys do 8 and 9 by yourself. It's not that difficult, okay? So those are easy. But definitely remember this formula, have it written down in your notes so you can easily access it during the quiz. Remember, during the quiz, okay, you'll have these notes with you, okay? But if you highlight the formulas, it makes it a lot easier than trying to dig through stuff. Okay, so here we go, finding the angle measures. So find the given angle measure for the regular octagon shown. Okay, and we're not given a whole lot of information. So what do? Okay, we don't know a whole lot, but we do know something that we just did on the last page. So let's calculate the central angle. Okay, when you're faced with a blank, when you're faced with a blank polygon like this, the only thing you can really figure out is the measure of the central angle. So let's look for the measure of the central angle is equal to the measure of angle HJG. Okay, because here, these are my radii of the circle and the polygon that extend to the vertices. Okay, and here's my central angle. So the formula is 360 divided by the number of sides. And we have 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. 360 divided by 8 is 45 degrees. So we know, okay, we should Measure of angle HJG is equal to 45 degrees. Okay. Since you kind of all know how I'm going to erase this so we have room to do the other ones. That'll be a little bit cleaner. Okay. Let's change colors. Okay, let's look at number 11. So the measure of angle GJK. Okay, so we know the central angle is 45. Okay, now we're looking for GJK. GJK. And you should go, oh, of course. So GJK is equal to the measure of HJG divided by 2. Okay, because remember that line here, that's the apothem, and it bisects that central angle. So we have 45 divided by 2 equals 22.5. Okay. Okay. So let me just make sure here that we know what we're looking at. So here is a radius. Okay, here is a radius. And here is the apothem. Okay, so just make sure you have that straight. Okay, so now we're looking for 11, 12, the measure of angle KGJ. Okay, so let's erase some of this. I bet you guys can anticipate what one KGJ is going to be, and you're right. KGJ is right there. Okay. Remember, we remember that GJK is 22.5, and so good old Pythagoras comes into play. We know 2 of the 3 angles in a triangle, so we're going to have 180 minus 90 minus 22.5. And that is going to be equal to 67.5 degrees. Okay. So remember, we know the total number of degrees in a triangle is 180. We're going to subtract out the 90-degree angle, angle K. We're going to subtract out the 22.5, angle KJG. And we're left with angle G, which is 67.5 degrees. Okay. And change colors. Do brown for a change. Okay, now we're looking for the measure of angle EJH. Okay, EJH. Okay, let's get rid of the yellow. EJH. Okay, so that's this whole angle right here. So we know this angle, okay, that's good old central angle, which is 45. Okay, so now how can we do this? So we know this angle is 45. So look, if we draw another radius out here, okay, these are more of our central angles. So this guy's 45 and this guy's 45. So what HJE is, or EJH is, 3 times 45 degrees, okay, is going to be equal to 135 degrees. Okay, that wasn't so bad. So this whole angle here, okay, is equal to 135 degrees. And we just did that because it encompasses or includes three central angles. Okay, and each central angle is 45. We multiply 3 by 45, and we get 135. So there are my answers. So hopefully you're able to follow that along pretty easily, because this is, kind of really basic finding angle sizes, and you'll definitely see problems like this on quizzes and tests. Okay, so we're going to ramp it up a little bit here. And these are multiple step problems. So let's look at number 14. So the first thing we notice is that the number of sides equals 3. So you can kind of think of it. It's a little bit tougher to think about here because, and I'm not going to draw this very well, but remember this whole triangle is inscribed in a circle. That one's really bad. Okay, still bad, but you get the idea. So we have number of sides is equal to 3. So what is the measure of our central angle? So remember, these are not the central angles. Bad. No bueno. Okay? But it's tempting to look at them that way. Okay, the central angle is made by radii going from the center of the circle to the vertices. So there's 3 central angles. Okay, we know from our formula that the measure of the central angle is equal to 360 divided by the number of sides is 3. So each of those 3 angles, those 3 central angles, is going to be 120. So this is 120, this is 120, and this is 120. Okay? So I'm going to erase this stuff just because it gets a little messy. Okay. So we need to use one of our formulas that we talked about, 2 pages ago, remember? One of them was 1/2 the apothem times the perimeter, and the other was A equals 1/2 the apothem times the number of sides times the length of the sides. So conveniently, we are given the lengths of the sides. And remember, these are regular polygons, so all these 3 sides are going to be the same. And there's 3 of them. Okay, so let's use this second formula. A is equal to 1/2. Okay, the apothem, and we'll talk about the apothem in a second. Okay, times the number of sides is 3 times 12. Okay, so let's just do the math on this. So we have 3 times 12 is 36 times 1/2 is equal to 18. 18 times the apothem. So what is the apothem? So if we draw 2 radii here, and then we bisect the radii down to the base, okay, there's my apothem. And we're given that it's equal to 2 times the square root of 3. So the area of the triangle is equal to 18 times 2 root 3. Okay. So 18 times 2 is 36, right? 36 times root 3. And we're done. Okay, there's our area. And if you want to, you can calculate what the square root of 3 is and multiply it by 36. But I'm perfectly happy if you just leave it as square root time, or 36 times the square root of 3. Okay? In some cases that won't work, but in this case it's just fine to leave it like that. When your final answer has a root in it, if you simplify it, like we multiplied the 18 times the 2, you don't need to go any further than that. Okay, so yeah, we're good. So again, let's go to number 15. And how many sides do we have? So we have one, oops, Chrome, come here. I'm getting tired of brown, it's kind of boring. Okay, about this kind of nice blue. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 sides. Okay, which is a nonagon. Remember that from a few chapters ago? So let's erase those. Yep. Okay. Now the measure of our central angle is going to be 360 divided by 9. Okay, 360 divided by 9 is 9 times 4, so it's 40. Okay, so if we draw some radii from the center to the vertex, and okay, whoopsie, that's wrong. Okay, there's my vertices going to consecutive lines. Okay, we know that the central angle is equal to 40 degrees. Okay. So, how do we figure out the area? So remember, we have our two equations, A equals 1/2 AP, and A equals 1/2 A times the number of sides times the length of the sides. So we can go either way. Okay. I have to pause here while I get the dog. She's barking at a squirrel. Okay, so how do we do this? So we need to find either the perimeter, and we definitely need to find the apothem. Well, conveniently, we're given one of these sides, and so we know the side S is equal to 6.84. We know N, the number of sides, equals 9. So all we need to do is find out that apothem. Okay. So invariably what you're going to find is that when you need to find the apothem, Pythagoras is going to come into play. It's either going to be Pythagoras or trigonometry. And some of the problems that we didn't do on that last page required trigonometry, and I really don't think that's really necessary at this point. Okay, so we're looking for this length here. It's the apothem. Okay, we're given here that this length is 10, and we're given that this whole length here is 6.84. Okay, now don't get this confused. I can see this happening. So it's this whole length that's equal to 6.4. Okay, so what we want is the half of that. So what we want is this length. So that length is going to be 3.42. It's going to be half of this guy, because remember that height bisects both this angle, okay, and it bisects this the edge, the side of the angle. So now, in order to figure out A, we know two sides, And again, Pythagoras comes into play. So a squared plus b squared equals c squared. Okay, we don't know what a squared is. We do know what b is. It's 3.42 squared. We do know what c is. C is 10. Okay, so we end up with a squared plus 3.42 squared is 11.7 is equal to 10 squared, which is 100. So doing a little bit of algebra, subtract 11.7 from both sides. A squared is equal to 88.3. And we take the square root of both sides. Okay, we get A. The apothem is equal to 9.4. Okay, I did that in my calculator. So now you're not done. You just know what the apothem is. So let's go back up here and figure our area. Our area equals 1/2. Our apothem is 9.4. Okay, our number of sides is 9. And our S, the length of our sides, is 6.84. So if I've done my calculations right, sorry, I had to double check my math here. So the area is equal to 289.33, okay, whatever the units are, squared. Okay, so that's not too hard. You just needed to find the apothem, and you needed to use the good old Pythagorean theorem. Okay, una más, one more. So, what are we given? We have number of sides. Oops. So S is equal to 1, 2, 3, 4, 5, 6, 7. So septagon. Okay. Get rid of all those. Okay, our central angle is equal to 360 divided by 7 is equal to 360 divided by 7. Hold on, I got to calculate that. Okay, so the measure of the central angle is 51.42. So what that means is, okay, this angle here is equal to 51.42. Okay, and let's write our equations to find area. A times N times S. Okay. So we have our S. We have our number of, we have our number of sides. Sorry, we don't have our S. Our N is equal to 7. Okay, so we have our N, that's the number of sides, is equal to 7. Okay, we are not given our apothem, and we do not know the length of the sides. Okay, so we need to figure that out. So, what do we do now? So we are given well, I should draw that the same way it's drawn. Okay. So I'm just exploding this triangle right there. Okay, so we've got a right angle here. We know that this length, the radius, is equal to 2.5, and we know this apothem is equal to 2.77. It's always good news when they give you the apothem. Okay, so I'm going to erase some of this. Okay, so we do not know that length there. Okay, so what we need to do is find out this length. We'll call it B, okay, which will give us this little length right there. And remember, we're going to need to multiply it by 2 to get the whole side, because you need that whole side, not just the little piece. Okay, so let's, good old Pythagoras. So we have, oh, whoops. Gosh, I drew this whole thing wrong. I'm sorry, you guys. This is getting long. I didn't mean for it to be that way, but okay, let me redraw this. Okay, so our height, our apothem is 2.5, our hypotenuse is 2.77, and this is what we're missing. Okay, so we have 2.5 squared plus b squared equals 2.77 squared. Okay, and I'm going to shorten this up a bit. If you do all those calculations, b is equal to 1.19. Okay, so that little piece right there is 1.19. Okay, so the whole side, s, is going to be equal to 2 times 1.9 is 2 times 9 is 18. 2 times 1 is 2. 3 is 3.8. 3.8, and we're given our apothem is 2.5. And then we got to keep our 1/2. So if we calculate all that out, okay, so if we do all that math, what we end up with is the area is equal to 33.25. And that's our answer. Okay, so hopefully I did that right. I think I did. And that should be it. So if you have any questions, let me know. And good luck on the homework.